Everyone, I am Vinita, Assistant Professor, Department of Computer Science from St. Josephs College of Arts and Science for Women in Ozu. Going to present about software testing fundamentals. Software testing is a very important process in software development. It ensures that the applications works correctly and meets user requirements. Introduction to software testing. Software testing means systematically evaluating the quality of software. It checks whether the software follows the specified requirements. It helps us identify defects before the software is deployed to users. For example, consider a banking application if it calculates account balance incorrectly. If it may cause serious financial problems, so testing ensures reliability, accuracy, and performance. Testing basically takes input process and checks whether the output is correct or not. If the output is correct, the system works properly. Next topic, why software testing is indispensable. Now let us see why software testing is very important. First, increasing complexity. Modern testing systems are very complex with multiple ingredients. Next, without proper testing, errors may go unnoticed. Second one, cybersecurity risk. Testing helps identify and security vulnerabilities and prevents hacking or data breaches. Next, third one, prevention of financial loss. If defects are found late, fixing them becomes very expensive. Yearly testing saves money. Next, fourth one, customer satisfaction and trust. When software works smoothly and customers feel satisfied and trust the company. Next, for example, if an ATM system fails and gives incorrect money, it will damage the bank reputation. So testing protects both users and companies. Next, core objects of software testing. Software testing is not only about finding bugs. Its first object is defect and detect. It identifies errors in the software. Second, verify functionality. It checks whether all features work according to the specifications. Third one, validate requirements. It ensures the software meets users' needs and business goals. And the next one, fourth, important system reliability. Testing increases system stability and reduces unexpected failures. And the next one, finally, enhance user confidence. When software works properly, users feel confident in using it. And the next topic, testing versus debugging. Many people think testing and debugging are the same, but they are different. Testing focuses on finding defects, and debugging focuses on fixing defects. Testing is performed by QA testers. Debugging is performed by developers. Testing ensures we are doing the right thing. Next, debugging ensures we are doing the right thing right. Next, for example, if login fails, a tester reports the defect. Then the developer finds the root cause and fix it. So, testing and debugging work together. And the next topic, error, fault, and failure. Now let us understand three important terms. First is error. Error is a human mistake, for example, using wrong logic while designing. Second is fault. Fault is a defect in the code caused by the error. For example, wrong formula in coding. Next, third is failure. Failure happens when the system does not perform correctly due to the fault. Next, for example, if a developer uses the wrong interest formula, that is an error. The incorrect formula in code is a fault. If a customer receives a wrong bank statement, that is a failure. So, error leads to fault and fault leads to failure. And next topic, essential software quality factors. To achieve high quality software, we focus on these factors. Reliability, software should work correctly for a long time. Usability, it should be easy for users to understand and operate. Next, efficiency, it should use minimum resources and give maximum performance. And the next one, maintainability. It should be easy to modify or fix. Next, security. It should protect data from unauthorized access. And the next one, portability. It should work on different systems and platforms. All these factors together ensure high software quality. And next topic, black box testing. Black box testing checks software without looking at internal code. It focuses only on input and output behavior. The tester does not know the internal logic. Next, testing is based on requirements. It verifies what the system does. And for example, in login testing, we enter valid and invalid credentials and check whether the system behaves correctly. We only see the output, not the internal processing. Next topic, white box testing. White box testing is completely different. Here the tester checks the internal code structure. It requires knowledge of programming logic. It testing loops, conditions, branches and different execution paths. For example, testing every if statements and loop to ensure they work correctly. So, black box testing external behavior and white box testing internal structure. Next topic, software testing lifecycle, STLC. Software testing lifecycle consists of 6 stages. First, requirements analysis, understanding what needs to be tested. Next, second one, test planning, creating strategy and allocating resources. Next, third one, test case design, writing detailed test cases. Fourth one, test execution, running test cases and identifying defects. Next, fourth one, defect reporting, reporting bugs to developers. Next, sixth one, test closure, preparing final reports and completing test process. This structures approach ensures systematic testing. Thank you.